Hi, my name is Patrick Reagan. Introduction to Computers, Part 3, Introduction to Computer Architecture, will give you an overview of the components that make up a computer from a computer architecture standpoint so that you can understand a little on how a computer functions. Computers are sometimes referred to as control flow computers because computers follow step-by-step set of instructions that tell it what functions to perform, such as retrieve data, manipulate the data, and write or output the data. At the center of the computer, logically speaking, is the microprocessor, sometimes referred to as just the processor or central processing unit or CPU. Everything is built around the microprocessor, which is usually a single integrated circuit. This integrated circuit is made from a single wafer with millions, if not billions, of microscopic electronic components such as resistors, capacitors, diodes, and transistors in a way that when certain electrical signals are sent to it, it can retrieve instructions and data, do mathematical calculations and comparisons, logical decision making, and output the results. It also controls other components. The processor typically is the fastest component on the computer. The CPU performs the following: read instructions from memory, communicate with all peripherals over the system bus, control the sequence of instructions, control the flow of data from one component to another, and performs the computer tasks specified in the program. The processor cannot successfully perform any task by itself. It requires memory for program and data storage and support logic. At least one I/O device, input-output device, used to transfer data between the computer and outside the computer. The control unit directs all of the operations of the processor, such as the computer's memory, its arithmetic and logic unit, input devices, and output devices. The control unit decides what to do with each program instruction that the processor is following. The arithmetic logic unit, or ALU, performs bitwise logical and mathematical operations on a binary number. Remember, processors don't work with decimal numbers like we do. Instead, processors work on binary numbers consisting of zeros and ones. When a user is ready to see data on the screen, the microprocessor will have instructions that convert that binary data to something that we understand, such as text or a picture. The data that is processed by the ALU is sent to the output unit so it can be sent to the monitor or to permanent storage so that it can be used later. The registers are small memory spaces in the processor to temporarily store data so that it can be manipulated. For example, you may have two registers called AX and BX. Step 1, you first move the number 3 into AX, and then step 2, move the number 5 to BX. Of course, the 3 and 5 are written in binary numbers consisting of on and off signals. Now that the two numbers are in the CPU, step 3, you can perform a bitwise function that adds the numbers together. We all know that 3 plus 5 is 8. Of course, the 8 will be represented by a binary number. Step 4, you can store the results in another register so it can be used for something else. You could also save it to memory or RAM, or output the number to a device such as a monitor or printer. The cache is used to store frequently used data instructions so that the CPU does not always have to grab it from the slower memory. Since the cache is part of the processor, it's typically running much faster than the data stored in the memory. The cache is a way to help speed access to the data you use frequently or the next set of data that is in sequence. The memory of the computer will contain the instructions that the processor is following and the data that it is manipulating. In computers, the primary memory is known as random access memory, or RAM. Instructions are fetched or read from memory, while data is both read from and written to memory. The instructions and data are moved along a bus. A bus is a group of signal lines that transfer electrical signals between different parts of the computer. Usually, Each signal line can carry a single bit of data, an off signal or an off signal. You take 8 signal lines and group them together in parallel. It is an 8-bit wide bus transfer that can send 8 bits of data in parallel at the same time. For each line that is added, the number of possibilities doubles. If you're sending 8 bits of data, you're sending 1 byte of data. For example, if you have 8 signal lines as shown on the screen, the off represents a 0 and the on represents a 1. 0010 1101 represents the value of 45. The 0010 1101 is a binary number that only consists of zeros and ones, while the 45 is a decimal number that you understand that has the digits ranging from 0 through 9. Most of today's microprocessors use a 3-bus system architecture. Data bus, which moves the actual data in and out. Address bus, that specifies the address that the data is going to or from. And the control bus, which has various signals to indicate the state of the current access, such as errors, read, write, and valid address. It also includes reset, interrupt lines, and clock input. If your bus has more signal lines, the bus can transfer more bits at a time. A 16-bit bus can transfer 16 bits of data, which is twice as much as an 8-bit bus. Many processors have 64-bit data buses, which means it can transfer 8 bytes of data at once. The address bus specifies the memory address that the data is going to or from. It also specifies how much memory you can access. A higher number of signal lines means that you can specify a bigger number in binary, which means you can identify more addresses. If you had one signal line, the only addresses you can send to is 0 or 1. But if you have 2 address lines, you can send to 4 different addresses. If you have 3 address lines, you can send to 8 different addresses. So for each line that is added, the number of possible addresses doubles. If you had a 20-bit bus, you can identify up to 1 megabyte of memory. The 20-bit bus was used in the original IBM PC. If you had a 32-bit address bus, you can identify up to 4 gigabytes of memory. A 36-bit address bus could identify up to 64 gigabytes of memory. Today's processor uses a 64-bit address bus, which means that the processor can access up to 16 exabytes. An exabyte is 1024 petabytes. For all intents and purposes, this is virtually unlimited. The control bus is similar to a football coach who is called in the plays for the team. The control bus sends signals out on what actions is doing and some of the support signals that make everything work. When you need to grab data, the control bus will send a read signal. The address bus will specify where the data can be found, and the data will be sent through the data bus. I/O is short for input-output. Input means that you're sending data into the processor, and output means you're sending data out of the processor. The main function of the input unit is to allow the user to input data that needs to be processed. Of course, the CPU is following instructions from the application software so it knows what to do with the input data. When you type something with the keyboard, you're entering data to be processed. The same with the mouse or joystick as you move a pointer on the screen. The scanner will digitize or convert a picture into pixels or dots, which can be processed by the processor. Common computer input devices are mouse, trackball, or trackpads, keyboard, camera, joysticks, microphone, scanner, or touchscreen. The main function of the output unit is to send data that's been processed to an output device and formatted for a user to understand it. The data is then sent out through the output unit to an output device such as a monitor or printer, which both can display or include text and images. 2 other common output devices are speakers and headphones, which send sound out. Common computer output devices are monitor, speakers, headphones, printers, plotters, projector, and touchscreens. You can create a document with your keyboard or mouse or scan a picture which inputs the data as pixels or dots. Both of these are input. They will be processed by the CPU and written to memory. When you're done modifying the text and picture, the text picture will be read from memory by the CPU and sent out to the monitor. If you decide to print the document, the CPU will read the memory again and send the text and images to the printer. It should be noted that peripheral devices have matured quite a bit, as devices that are primarily an input device may also act as an output device and vice versa. For example, you could have a racing wheel, a specialized joystick that is used as a steering wheel. While it is primarily used to steer in a game, it could shake or vibrate as feedback as you're driving or flying through a course in a video game. A printer that is primarily an output device may also signals back to the computer to indicate that print job has completed printing, the printer is online, or that the printer is out of paper. Of course, a touchscreen is a combination of monitor, an output device, and an input device that allows you to interact with the screen by touching it. You can buy a multifunctional printer that is a printer and a scanner. The primary memory or storage in a computer is RAM, which is temporary memory or short-term memory. The primary memory is relatively expensive as well as faster compared to secondary storage. Unfortunately, primary memory is volatile, which means that it does not retain its content when the power gets off. If you need something long-term, you need to store it in long-term storage, also known as secondary storage. Common long-term storages is a hard drive and SSD drive, which allows data to be retrieved at a later time. Other long-term storage devices are USB drives and flash drives. Of course, today, you can always store remotely on a shared folder on a server or in the cloud. To keep everything in perspective, this slide shows the slowest computer components to faster computer components, as well as the relative size of each. The processor is the fastest and it has the smallest amount of built-in memory. The RAM is the next fastest component and more memory than a processor. The slowest, as well as the largest, is the drives, which is used as long-term storage. To help speed access between disk and RAM, and between RAM and processor, there is typically a cache memory that usually stores data that is likely to be used again or is the next set of data that is in sequence. Since the processor has to wait for the slower memory to feed it data instructions, the processor includes the cache to store what it thinks will be the data instructions it needs next. If it's not in the cache, it will then pull it from the slower memory. Most hard drives will have its own cache to help feed the memory on what it thinks the memory needs next. Question: what is a computer built around? Answer: microprocessor, also known as CPU and processor. Question: which of the following is considered an input device? Answer: keyboard and stylus. A stylus is a device that looks like and functions as a digital pen. Question: what type of device is a hard drive? Answer: secondary storage. Question: what is the fastest component within the computer? Answer: the processor. Question: what should carry signals between the processor and memory? Answer: the bus. Question. In computers, what is used to increase performance when a faster component has to wait for a slower component? Answer. A cache. For more information, visit these sites. In summary, at the center of the computer is the microprocessor, sometimes referred to as just processor or central processing unit or CPU. Everything is built around the microprocessor, which is usually a single integrated circuit. In computers, the primary memory is known as random access memory or RAM. The instructions and data are moved along a bus. A bus is a group of signal lines that transfer electrical signals between different parts of the computer. The primary memory in a computer is RAM, which is temporary memory. If you need something that has memory for a long time, you need to store it in long-term storage, also known as secondary storage. Thank you for watching this video. The next video will be Introduction to Computers, Part 4, Introduction to Software. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.